Today we're doing the first part of section 4.1, and the objective is converting back and forth between radians and degrees. So the first definition I'm going to give you is a radian. We are familiar with degrees. What we are not familiar with is radians. And a radian is the measure of the central angle of a circle that intercepts an arc equal in length to its radius. So that is what a radian is. Now this is very wordy and very confusing, so I'm going to draw a picture to kind of help you understand. So here we have our circle, and let's say the radius is right here of length r. So imagine picking up this green segment and I would lay it on the arc of the circle. So this also has a distance of r. And now I'm going to close this in, so I'm going to go from the edge of this green line back to the center, and this is also a radius, so it also has a length of r. So this angle that we just formed right here has a measurement of what we call 1 radian. So that is what a radian is. Radian measure is found by taking the length of the intercepted arc and dividing the length of the intercepted arc by the radius. So to kind of go back to that picture that we had just drawn, so here's my circle and here's my length r. So imagine here's 1 radius, and then I laid it down again, and there's another r. And now I close this in. So the length of the intercepted arc is 2r, because it has a length of 2r, divided by the radius. So this would be a measure of 2 radians. Okay? So to kind of bridge the gap between radians and degrees, to kind of help you understand the two, if we take this whole idea, this formula, the length of the intercepted arc, and we think about a whole circle. So if I had a full circle, the vocab word that we use to find the entire arc is what we would call circumference. So the circumference of an entire circle is 2 pi r. So this is assuming that my intercepted arc is the whole way around. And then that formula said, well, I take the length of the intercepted arc and divide it by the radius. So notice the r's would cancel. So 1 full circle has 2 pi radians. And to kind of tie this together, we know there's 360 degrees in 1 full circle. So 2 pi radians equals 360 degrees. Similarly, another important fact is that pi radians would equal 180 degrees. So that would be equivalent to half a circle. So half a circle has pi, half a circle has 180 degrees. So now I'm going to give you the actual conversion to go back and forth between the two. So if you are in degrees, so let's say we start in degrees, and the goal is to change degrees into radians, I multiply by pi over 180 degrees. Similarly, let's say you are in radians and you want to convert to degrees. You multiply by 180 degrees over pi. So the way I used to remember is that if there's no pi, you need to introduce the pi. If there already is a pi in the problem, you need to get rid of the pi. So kind of look at it that way and figure out where the pi goes in the fraction, and that will kind of help you remember. So our first example is converting each degree into radians. So we're converting from degrees to radians. And we're going to do like 3 problems within the section. So just one direction, and then we'll do 3 problems. So the first problem is 30 degrees. So if I want to convert this 30 degrees, I'm going to multiply the problem by pi over 180. So now I'm at 30 pi over 180 degrees. And for sake of converting or reducing, I can say that these zeros are going to cancel out. So now I'm at 3 over 18. Divide those both by 3. And now I'm at pi over 6. So 30 degrees is pi over 6 in radians. Example 2. 90 degrees. So again, we're going to multiply by pi over 180. So I'm at 90 pi over 180 degrees. Simplest thing to do when you have 2 zeros is cross those zeros out. So I know those zeros are gone. And now I'm at 9 over 18. 9 over 18 reduces to be 1/2. So this is pi over 2. And to kind of tie this all together, we discussed that 2 pi is a full circle. 1 pi is half a circle. So it only makes sense that pi over 2 is equivalent to 90 degrees. And if you think about it, 90 degrees would be a quarter of a circle, or a half a pi if the whole thing was 2 pi. So the last problem is negative 135 degrees. And we'll discuss negative angles in a little bit. That's going to be tomorrow's lesson. So here, we're multiplying again by pi over 180 because we started in degrees. So I'm at negative 135 pi over 180. And this one's not as easy to simplify just looking at it, but obviously they're both divisible by 5. So we would start with that. And it ends up reducing to be negative 3 pi over 4. So that would be our final answer. So this is how you convert from degrees to radians. So the next 2 examples I'm going to show you is vice versa, going from radians to degrees. So same deal as before, just write the directions one time. So convert from radians to degrees. So here's our first problem. So the first problem is pi over 3. So notice, the problem appears different right off the bat. You have a pi in the problem, whereas in the other ones we had degrees. So I need the pi to go away. So in this problem, we're going to put the pi in the bottom of the fraction. And the reason we would put the pi down at the bottom is that so that these pi's can cancel. And now I'm dealing with 180 divided by 3, which is 60 degrees. So pi over 3 is 60 degrees. Second example is negative 5 pi over 3. And just like you could have negative degrees, you can have negative radians. And I'm again going to multiply this one by 180 over pi. So the pi's are going to cancel. I have a pi in the bottom and I have a pi in the top. So now I'm dealing with 5 times 180 over 3. Now, obviously you could just type 5 times 180 in the calculator and divide that answer by 3. Let's say you don't have a calculator handy to do this by hand. I know this 180 divided by 3 is 60, and I still have a 5 there. So 5 times 60 would be 300 degrees. So I don't care how you go about it. You could type the whole thing in a calculator, or if you do it by hand, that's an easier way to go about it. So negative 5 pi over 3, that should be a negative 300 since our original angle was negative. So that's all for today.